Hi, welcome to my tutorial on integration. What I'd like to do in this tutorial is show you how to integrate, why we integrate, and the relationship between integration and differentiation. Throughout the tutorial, I'm assuming that you're familiar with differentiation, and if you're not, please view this video or my tutorial on my website on differentiation. So let's have a look here. We've got this expression here, y equals 3x cubed plus 5x squared plus 2x. What I'm going to do to start off with is I'm going to differentiate this expression. So if you remember, if I'm differentiating this, the power gets multiplied by the coefficient to give me 9, and then the power is reduced by 1 to give me 9x squared. Same thing happens on the second term. That's going to give me 10x to the 1, but we don't have to write the 1. On the third term, if you imagine, this really is a 1. So 1 times 2 gives us the 2, but then if I reduce the power, I get x to the 0, and x to the 0 is just 1, and 2 times 1 just gives me 2. So that is my differentiated function. This could be written as dy dx. Another way you might see this is y equals the integral sign. This here is the integral sign. 9x squared plus 10x plus 2 dx, which means we integrate with respect to x. So, in general, let's have a look at what we've done here. We've differentiated a function to get our gradient function. Now what integration is starting off with our gradient function and trying to do the reverse to get back to our function. It's the opposite to differentiation. So if we have a look at what we've done, or what we could do to get from our gradient function back to our function, we should be able to generalize this. So in case of dy dx, if dy dx is equal to ax to the n, what would the function, or y, actually be equal to? Well, let's have a look at what's happened here. To get from the x squared to the x cubed, we would be adding 1. So we'd have ax to the n add 1. We're adding 1 to the power. And to get from the coefficient to this coefficient, you can see we're dividing it by 3. But if we have a look at the next term, this would become, 10x to the 1 would become x to the 2, and 10 to the 5 is divided by 2. And what you should see is that we're dividing by what the power has increased to. On this one, the 2 went up to 3, and we divided by 3. On this one, let's just put the 1 in there, the 1 went up to 2, and we're dividing by 2. So we could say that we have to divide it by n plus 1. It looks pretty straightforward. There is a slight problem though with this. Let's have a look at this second one here. And this is almost identical, but if you have a look, it's got the plus 5 written on the end there. But let's differentiate this. We're going to get 9x squared plus 10x plus 2. But what happens to the 5? Well, if you remember from differentiation, let's just do a little sketch here. If I have got, say for example, the graph of y equals x squared, and I had the graph of y equals x squared, let's say minus 3, then the gradient of both these graphs at any point on that curve would be the same. The gradient function is the same for both of those two curves. The only difference is where they cut the y-axis, and that is what the last term there tells you, where it actually cuts the y-axis. It doesn't make any difference to the gradient function where it cuts the y-axis. The gradient function will be the same. So that's where we've got a little bit of a problem, because this one here and this one here both differentiate to exactly the same thing. If we're working backwards and we're trying to integrate this function, we can only get part of that curve, because with this one there wasn't a number on the end, but with this one there is. We don't know whether there's a number on the end or not. So our formula has to take that into account. So what we do is we write plus c. C is known as the constant of integration. We're not going to be able to know what it is at this stage, but it has to be there to show us that there could possibly have been a number on the end of that equation. Okay, let's finish off just by doing an example here and integrating this expression here. So what we're going to do, we've got the integral of this expression here with respect to x. We're going to integrate that to get back to find out what y would have been. So we're going to write down y is equal to. So look at the first term. We're going to raise the power by 1. So I get 4x to the 4. But of course I need to divide that by the power raised by 1 as well. Same with the second term. Raise the power by 1, 6x cubed divided by 3. Third term, 4x raised to the power by 1, you get 4x to the 2 divided by 2. And then 2 just becomes 2x. And then finally we need our constant of integration plus c. Let's tidy this up a little bit. Y is going to equal x to the power of 4. 6 divided by 3 gives us 2x to the power of 3. 4 divided by 2 just gives us 2x to the 2 plus the 2x and plus our constant of integration c.